Lesson 8.3, Sum and Difference and Cofunction Formulas. This will be our last lesson for Unit 8. Before we begin this lesson, though, I would like you to turn over your note-taking guide and go ahead and take a note of these sum and difference formulas. There are 4 of them I need you to copy down. We do have tangent formulas for sum and difference, but we are not going to take note of those. Focus solely on sine and cosine. So pause your video now and return so we can get started. Okay, so let's look at number 1. So for positive acute angles A and B, it is known that sine A is 12 over 13 and cosine of B is 8 over 17. We are being tasked to find the value of sine A minus B in its simplest form. So I just went ahead and brought over the formula for sine A minus B. And what we are going to need is to find 4 different values to substitute for sine A, cosine B, cosine A, and sine B. Now, what you're going to notice is that in these problems, we are going to be given some information that possibly can be substituted into our formula. So they gave us sine A. So I'm going to just highlight here what they gave us. They gave us sine A to be this value, and they gave us cosine B. So they gave us these right here. Okay. So we still need to figure out what these 2 values are right here. So how are we going to do that? So they did tell us that we have positive acute angles, okay? So what I am going to suggest is that when you draw your triangles, draw them as an angle found in the first quadrant, okay? So for instance, don't do this right now, but here is our quadrants, right? And I want us to draw a positive acute angle. So let's just draw, this will be the way we would draw these angles, and it would be a right triangle, of course. Okay, so let's go ahead and do that for angle A and angle B because there are 2 angles, all right? 2 separate angles. So here we have 2 different triangles, one for our angle A information and another one for our angle B. Please bear in mind, I just randomly drew 2 right triangles that are acute, and the dimensions or the lengths of those sides, do not worry about them. They are just line segments that are going to represent the values that are given to us, okay? So it's not drawn to proportion is what I'm saying. So sine A is 12 over 13. Now what you need to remember is your good old SOHCAHTOA, if you use that mnemonic type sounding thing. So sine is always going to be opposite over hypotenuse. Cosine is always going to be adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so please remember those. So if you're standing at sine and they're telling you to find the sine of A, sine is label opposite over hypotenuse. So my opposite side is going to be 12 and my hypotenuse side is 13. Over here for cosine of B, cosine B is here, they said 8 over 17. So A over H. See the cosine over here? So our A is adjacent side. So if I'm standing here, my adjacent side is going to be next to where I'm standing. So this is the length of 8, and my hypotenuse is 17. So on both of these problems, notice that we are looking for a leg. And remember, a leg is always the 2 side lengths that form the 90-degree angle. So I'm looking for a leg, I'm looking for a leg. So when it comes to Pythagorean theorem, we know that the leg squared I'm going to just do it like this, plus another leg squared is always going to equal the hypotenuse squared. So if I'm looking for a leg, I know I'm going to call this, let's call it x, okay? X squared plus 12 squared equals 13 squared. And I am going to subtract. So x squared is going to be 13 squared minus 12 squared. And then I am going to square root. Okay. And so let's figure out what x is. So I'm going to come over here and let's see, 13 squared, which is the hypotenuse squared minus the leg squared. And then I'm going to square root 25, and you guys can't see anything I'm writing here. There we go. Let's see if I can reduce so there we go. So 13 squared minus 12 squared is 25, but then I need to square root that, and we know that's 5. Okay, so x is 5. So I figured out that length. So I can come up here if I want and go ahead and label it. And then over here, since we're looking for a leg, I'm not going to do all this all over again. We know that we take the hypotenuse squared. So let's call this, I guess, let's call it y. Y is going to be 17 squared, the hypotenuse minus the leg, and then I need to square root it. So let's come back over here, and we're going to have 17 squared minus 8 squared is 225, and the square root of 225 is 15. So y is going to be 15. Okay, so I'm going to erase this and I'm going to put a y of 15. So now that we have all the labeling, we should be able to figure out what cosine A and sine B is. All right, so let me bring this down. The sine of A minus B, which is what we're looking for, is equal to. So let's substitute. The sine of A was given to us to be 12/13. And then the cosine of B was given to us to be 8/17. So I'm going to put a dot there to kind of separate and show the multiplication. Then there's a minus, and they want us to use cosine of angle A. So cosine is adjacent over hypotenuse. So 5 is my adjacent over 13. So 5/13 times the sine of B. So I need to go here to to B, and do sine, which is opposite over hypotenuse. Opposite over hypotenuse. So 15/17. So all I did was use those pictures to figure out those values. So now all we do is type it into the calculator. And you can use if you're using this calculator, just press alpha y equals to get the stack fraction. And 21/221 is our final answer. So 21/221. Okay, that is it. That's all you need to do. Okay, so now let's proceed to number 2. So our equation is cosine A plus B equals, you can read cosine A cosine B minus sine A times sine B, and they gave us some information. So in this case, they gave us tangent of A is 24/7 and cosine B is 60/61. So unfortunately, in this particular problem, notice that only one of those 4 values was given to us, and that was specifically cosine B. So I'm going to highlight again, showing which one we have, and we need to find 3 other ratios. So I want you to pause this video and construct your triangles so that you can find those missing values, and then unpause to check to see if your work is correct. Okay, here we go. So here's kind of a sketch, not drawn to scale, of our acute angle for A and for B. So tangent is 24 over 7. So we had to, 24 over 7 is opposite over adjacent. Again, going right back to up here, I'm using the ratios for trig functions. So label accordingly. So make sure you know those so that you label correctly. So if I'm standing here, this is my opposite over adjacent. In prior sections, we used to label. So if it still helps you to label OAH, go ahead and do that. For B, cosine B, they gave us adjacent over hypotenuse for cosine. So here again was my adjacent labeled side and my hypotenuse labeled side. So over here in the first one, I was missing a hypotenuse value, so I had to take the sum of the legs and square root them. Over here, I was missing the opposite side, which is a leg. And when you find legs, so my opposite side, I'm going to subtract one of the legs squared from the hypotenuse squared. And so these are the answers you should have got. Okay, so I'm going to put those values in for those spots. So my hypotenuse was 25. So, well, actually can leave my letters there. So let's put the H back there a second. So here is 25. And for my opposite was 11. So returning back to our formula that we're looking to evaluate, cosine A minus B, the cosine of angle A. So I'm standing at angle A, cosine as adjacent over hypotenuse. So we're going to put 7 over 25 times cosine B. They gave it to us, 60 over 61. Then there was a minus sine of angle A. So sine is standing here, opposite over hypotenuse. So 24 over 25 times the sine of B, which would be standing over here, opposite over hypotenuse, 11 over 61. Put that in the calculator, and the result is 156 over 1525. Simple as that. So again, notice that all you're doing is right trig trigonometry, right angle trigonometry, which we have reviewed so many times, and you are plugging in values that you find into the given formulas. Turn over now to the other side, and I would like you to add now the other last two sum and difference formulas for tangent. So the tangent of A plus B and the tangent of A minus B. Go ahead and pause the video, then resume when you're ready to continue with the lesson. Okay, so now that you've copied that down, let's look at problem number 3. We're going to change it up a little bit and show you another way we can use sum and difference formulas to evaluate the exact values of a trig function at an angle. All right, so for our problem, we are going to find the exact value of tangent of negative 255 degrees. Now, when you end up with an angle such as a negative angle like this one, I would like you to find the coterminal angle. Coterminal just means, co means to share. Another angle that shares the final side of 255 degrees, okay, as you find that angle. So what I'm going to do is um, take that number, the negative 255, and I'm going to add an entire revolution to it so that it would just end up back in the positive range. So 360. One revolution is 360. And negative 255 is the same thing as 105, okay? And all that means, if you look at a picture of a unit circle, if I start from right here and I say I go negative 255 degrees, that means I went this way. So I went 90 kept going, negative 180. And if I keep going, I'm going to hit negative 270. So negative 255 is somewhere around here, right? So all I'm doing is, well, instead of going backwards, what is the positive angle that would end up at the same spot, that would share the same terminating side? So that I'm telling you to go this way, rotate this way. So you, instead of going negative 255, what is that, clockwise, you're going positive 105 counterclockwise. Okay, so that's what you're doing. So add 360, that degree measurement is going to work out for us. So what you're going to do is come over here and you are going to tell me tangent of negative 255 degrees is the same thing as finding the tangent of, what did I say that was? 105 degrees. 105 degrees. So first, find a coterminal angle. All right, and that's what this was. And I'm going to put in parentheses here, add 360 degrees, however many times you need to find a coterminal angle. All right, so all that means is, let's say you were at negative 560. And if I added 360, notice you're still in the negatives. So just add 360 again. Now I'm good. Use 160 degrees. That's all I mean. So keep adding increments of 360 until you get a positive coterminal angle. All right, now that you have a positive coterminal angle of 105, they want us to use the angle sum and difference formula. So I need you to, and we're going to use the unit circle for this problem, I need us to find either, and I said either, okay, the sum of two angles or the difference of two angles that would result in 105 degrees. So I'm going to say this one more time in different words. I need you to find two angles that either add or subtract, whichever one you want, and that will give me 105 degrees. Whether you choose sum or difference, after you do the work, both ways will arrive to the same answer. So there's not a which one is the right one to pick. They're both correct, okay? I'm going to tell you, most students tend to like to pick the addition one because they tend to find those two numbers faster when you're adding. But let's take a look over here, okay? So if you had to pick, and we're working in degrees, so we're looking at these angles right here. Are any of these two angles listed here, any of them, could they add or subtract to 105? And just because we're doing this recording, I am just going to give you two angles that add to 105. So I'm going to use a 60 and a 45. Those two add to 105. And if you figured out two other ones that you want to use, go ahead and use them, whether they were adding or subtracting, okay? But you have to use these angles. So tangent of 105, I am going to rewrite it as a sum of tangent of 60 degrees plus 45 degrees. And so because I wrote it like this, I now can use the formula that you guys have written at the back of your page, right? I'm going to rewrite this using the formula. So I think I'm going to go down here. I'm going to put my division bar, because I know tangent has that. Wow, that's a horrible division bar. Probably should have used a ruler. Okay, so here's my division bar. And when I am, what am I doing? Adding tangent. Let me get the formulas because I do not know them off the top of my head. So the adding of tangent says we need to take the tan of the first angle plus the tan of the second angle. So tan of that first A angle plus the tangent of the second angle. And then underneath, I'm going to do 1 minus, and I'm going to do the multiplication of those two at the top, tan 60 and tan of 45. So this is my setup, okay? That's me setting it up. All right, so if I call this A and this B, if it makes it easier, so tan A plus tan B over 1 minus tan A times tan B. And so now we're going to use the unit circle. So, okay, so tangent of 60. So I'm going to come over here to 60 degrees. Tangent is y over x. So here's x, here's y. So I'm going to take my y and divide it by x. So square root of 3 over 1. So square root of 3 divided by 1 is just square root of 3. So I'm just going to put square root of 3 plus tan of 45. So I come over here to 45. Tangent is y divided by x. Remember, I'm just ignoring these because they're going to cancel out when I divide anyhow. Square root of 2 divided by square root of 2 is, yes, it's a 1. So I didn't have to really make my line that long, right? Now, downstairs, 1 minus, multiply the two answers you got upstairs. Well, if I multiply these two answers, square root of 3 times 1, it's just square root of 3. Okay, so far so good? Okay, now, I know you're going to be upset with me when I say this, but this is not where you will stop. We are almost there, okay? And the problem is we have to, you've seen this word so many times already, we have to rationalize, okay? When you have a radical in the denominator, we have to multiply, and this one specifically, the radical is subtracting from a 1. We have to multiply top and bottom by the conjugate, okay? So what we're going to do, rationalize, and I'm going to put here the words multiply by the conjugate. And what the conjugate is as follows. You're going to take whatever's in this denominator, and I need you to multiply top and bottom where you keep that number the same and change the sign to the opposite. And do it top and bottom. Keep, change this, and then write that. Okay, so if this was a plus, make it a minus. If this was a minus, make it a plus. So you're multiplying top and bottom because remember, this is a 1. I'm multiplying by a 1, so I'm not changing anything. And then I'm going to run out of space, so I'm going to have to go like this. Okay, you are going to distribute. Be patient with yourself. I know it's like, oh, but just be patient with yourself, okay? First, so multiply first terms. Square root of 3 times 1 is square root of 3. Outer terms, square root of 3 times square root of 3 is just a 3, right? Because square root of 3 times square root of 3 is square root of 9. Square root of 9 is a 3. So I'm going to put a plus 3. Inner, multiply the inside ones. 1 times 1 is a 1. And then the last terms, this times that, 1 times square root of 3 is positive square root of 3. Over, okay, so all you did was distribute. This is difference of squares. This is difference of squares. A minus b times a plus b. Let's not FOIL because we know the correlation of a minus b times a plus b. All we have to do is take this number and square it. Put a minus because it's difference of squares. Take this number and square it. It gets rid of the radical. Every single time, you guys, that's all it is. If you want to FOIL, distribute, you're just going to end up right back here. with 1 minus 3, you're wasting time. I'm just going to do it really quickly over here just to prove a point, because as you can see, I'm trying to sell you guys on these little shortcuts, these patterns, so that you don't bog yourself down with so much math work, right? So if you wanted to do the distribution, 1 times 1, 1 times square root of 3, negative square root of 3 times 1, negative square root of 3 times square root of 3 is just going to be a minus 3. Those two zero out. 1 minus 3. Look, we're right there. So why do all of that? Okay, if you just need to remember a minus b times a plus b is the same thing as a squared minus b squared. Just square that term. See, a square. Take that a, square it. That's what it says. Minus, always minus. Take that b, square it. Okay? All right, so let's just bring these together. I'm going to go over here. Square root of 3 plus square root of 3. How many of those do we see? We see 2 of them. And then 3 plus 1 is a 4. So I'm going to put 4 plus 2 square root of 3, or 2 square root of 3 plus 4, it doesn't matter to me, over negative 2. Okay, and since this 2 can go into both of these, 4 divided by negative 2 is a negative 2. 2 divided by negative 2 is a negative 1. So negative, you can write the 1 if you want, square root of 3. And if you don't want to write the 1, you can write it as negative 2 minus square root of 3. Either one works, all right? Doesn't matter. Okay, so yes, that one is a little bit long, but if you really, really look at this problem, you guys, it's not a hard problem, okay? All you did was take a number, you keep adding 360 until you find a number, then you look at the unit circle, try to find 2 numbers that add or subtract to that number, find your values in the unit circle, and then do algebra, okay? All right, we're not going to do 4. Let's go to 5, and we should be able to wrap it up after this one. So go ahead, if you have a highlighter, I want you to highlight this statement right here. Cofunctions are equal when the angles are complementary. In other words, when they sum up to 90 degrees. So go ahead and pause, highlight. Okay, so are you ready to finalize this with something super easy? I'm sure you are. So here is the deal with this one. All they're telling us is if you have an equation that has cofunctions set equal to one another, you can go ahead and assume that those angles add up to 90 degrees. All right. So which are the cofunctions? So cofunctions are paired up like this. Okay. So these are not reciprocals. Remember that. All right. So the C, where is it? Yes, the SEC, the SEC is going to be with the CSC. I'm going to just bubble them up here. Cofunction of sine pairs up with the cosine. I guess I should put theta. You can't even see what I'm writing. Secant and cosecant, sine and cosine, and then tangent and cotangent are cofunctions of one another. So with that in mind, I have a secant value being set equal to a cosecant value, and this only can happen, cofunctions are equal, when the angles, this is the angle, and this is the angle, are complementary. Complementary, back in geometry, means they add to 90 degrees. So all you're going to do is say, take my first angle, and I'm going to add it to my second angle and set it equal to 90. And then I'm going to solve for x. So first I'm going to combine like terms. So I've got a 5x, and 30 plus 15 is a 45. I'm going to subtract 45 on both sides. So I'm going to end up with a 5x equals a 45. And then I'm going to divide by 5 on both sides, and I'm going to end up with x equaling 9. So what are my two angles? Well, if we call this angle 1, and let's call this angle 2, all right, for instance, we are going to say angle 1 is equal to x plus 30, which in our case, x is 9 plus 30, so 39 degrees. And then angle 2 was 4x plus 15, which would be 4 times 9 plus 15. 4 times 9 is 36 plus 15. And 36 plus 15, that's 6 and 5 is 11. What is that? 51 degrees. And so those are your answers that you would type into your DeltaMath platform. And you can always make sure that those two angles you found indeed add up to 90 degrees as stated by our sentence here that you highlighted. And that's it. That's all you do for this particular type of problem. That's dealing with cofunctions. So we are done, but if you want to tackle this problem on your own, go ahead and work it out. I will tell you right now that angle 1, I'll tell you the answers so that you can see if you can arrive to the correct answers. But here are the two answers. Angle 1 and angle 2 should end up being those answers right there. Okay? And those two numbers do add up to 90 degrees. All right, my dears, thank you for watching. Go tackle that homework. I'll see you around.